Okay, so let's look about what's similar and what is different compared to what we have been doing here. The instructions are the same. We're still solving the equation between 0 and 2 pi. So we still want our answer in radians. We could just as easily give our answers in degrees. It's just when you're dealing with just equations, the tradition is that you use radians. And if 2 pi is our answer, then we use 0 instead because we have the equal to with the 0. We don't have the equal to with the 2 pi, but just remember those are the same answers, or the same angles. All right, as far as the equation goes, what's similar, what's different? In this case, we only have one trig function. We have cosine. What's different is it's not just cosine of theta. We are adding something to the angle. That pi over 3 is inside of the trig function. It is being added to the angle. So it's going to change how we solve this here in a minute, okay? But the same original premise applies. We've got to get that trig function by itself. Right now, the problem is it's being multiplied by 2 over 5. So to take care of that, we will multiply by the reciprocal, 5 over 2. Both sides by the reciprocal. 5 over 2 times 2 over 5 is 1. That's the whole point in doing it. When we multiply the square root of 3 over 5 times 5 over 2, those 5's cancel, so we've got the square root of 3 over 2. That's good because now that's a value that we're used to seeing, we're familiar with. Now, that pi over 3 is inside the angle. We cannot take it out of that set of parentheses. Okay, you cannot take it out of the set of parentheses. So for the moment, we are going to disregard what's in those parentheses. We're just going to focus on the cosine being equal to the square root of 3 over 2. So when we look at our unit circle, we're looking for the x-coordinate to be the square root of 3 over 2. That happens at pi over 6, and that happens at 11 pi over 6. So we are going to, normally we would say that theta is equal to that, but we don't have just theta, we have theta plus pi over 3. So that is what we're going to set equal to our answer of pi over 6. And we're also going to set it equal to the other answer of 11 pi over 6. Okay, so we temporarily ignored what was in the parentheses. We just got the answer. Where is cosine equal to the square root of 3 over 2? That's at pi over 6 and 11 pi over 6. But it wasn't just theta anymore. It's theta plus pi over 3. Our whole goal is we got to solve for theta. Now we've got to get theta by itself. Now we can subtract that pi over 3. Now, I would really love for you to manipulate fractions here, but if you have to, go to your calculator. Don't type in the pi. Y'all know that. Just type in the fraction, 1 over 6 minus 1 over 3. You know it's going to be a fraction, so you might as well go ahead and math enter, and we get negative 1 over 6. So that's negative pi over 6. Okay, we had to leave the pi out, put it in the calculator, so you got to put the pi back in. But here's the problem. Our answers have to be positive. They have to be between 0 and 2 pi, so that's why we learned about coterminal angles last week. We need to find a positive coterminal angle here for negative pi over 6. So we add 2 pi to it, which is 12 pi over 6. So negative 1 plus 12 is 11 pi over 6. Now, very rarely does it turn out that your answer was one of the original values that you got when you were solving it, but sometimes it does happen. Let's solve the other one for theta. Subtract pi over 3 here. If we're subtracting pi over 3, that's really like subtracting 2 pi over 6. 2 over 6 reduces to 1 over 3. So 11 minus 2 is 9 pi over 6, which of course reduces to 3 pi over 2. So, two different looking answers. We're used to our answers when we get them, they're usually always over the same denominator. In this case, they are not, but we can check them. Okay, I think I put my calculator in degree mode, so I'm going to go back to radians. And I'm going to go to the original equation, 2 over 5 cosine of, let's try 11 pi over 6 first, plus pi over 3. Whoops, I divided. Okay, and that's supposed to be equal to the square root of 3 over 5. Make sure you close the parentheses after the 3. Okay, I get the same decimal value. Usually I don't check both solutions, but I definitely would here. Just because because I had to do that extra step, I want to make sure that I did that extra step of subtracting the pi over 3 correctly. And I get the same decimal. So those are my two solutions to that equation. Okay, look at another one. Square root of 2 is equal to 2 sine of negative 3 theta plus pi over 6. Square root of 2 is equal to 2 sine of negative 3 theta plus pi over 6. All right, so we've added another element to this here. Not only are we adding something to our angle, we are also multiplying the angle by 3. I want you to observe that at the beginning of the problem, because that means you are going to have 3 times as many answers as normal. So normally we have 2 answers, so this one is going to have 6 answers. Okay, there are going to be 6 answers to this equation. Well, let's see how we come up with those 6 answers. All right, we need to start, same premise though, our trig function is not by itself, it's being multiplied by 2, so we're going to divide both sides by 2. So we've got the square root of 2 over 2 is equal to the sine of negative 3 theta plus pi over 6. Okay, so again, we're going to ignore what's in the parentheses for the moment. We're just going to focus on where is sine equal to the positive square root 2 over 2. So I know that's at my pi over 4 angles. My positive one would be at pi over 4 and at 3 pi over 4. Positive y coordinates at pi over 4 and 3 pi over 4. Okay. So I'm going to write those down, pi over 4. I'm going to set that equal to the negative 3 theta plus pi over 6. I'm going to take the 3 pi over 4. And I'm going to set that equal to negative 3 theta plus pi over 6. So that's only 2 answers. I'm supposed to have 6. Here's where the other 4 come from. We are going to find coterminal angles for pi over 4 and 3 pi over 4. We're going to find coterminal angles. We're going to find 2 each. So that will give us the extra 4. Now, normally, I would add 2 pi to the pi over 4 and the 3 pi over 4, but if we think about this a little bit, in the process of solving for theta, we're going to end up dividing by a negative 3. So if we divide by a negative, we're going to get a negative answer, and we're not allowed to have negative answers. So if I go ahead and get negative coterminal angles for pi over 4 and 3 pi over 4, when I divide by the negative 3, I'm going to end up with a positive number. So it's going to save me a little bit of work down the road. So this time I'm going to find negative coterminal angles. So I'm going to subtract 2 pi from pi over 4. So that's going to give me negative 7 pi over 4. I'm going to subtract it from 3 pi over 4 as well. So if I subtract 8 pi over 4 from 3 pi over 4, I'm going to get negative 5 pi over 4. Okay, so that's 4. I need 2 more, so I got to subtract 2 pi again. Let's see where I've got room. Let's go over here. If I subtract 2 pi from negative 7 pi over 4, that's going to give me negative 15 pi over 4. If I subtract another 8 pi over 4 from 5, that's going to give me negative 13 pi over 4. Y'all tell me if I did anything wrong with my arithmetic. second guessing myself. Okay, so that's where my 6 answers are going to come from. I have 6 equations set up. Now I just have to finish them all out. I'm going to do the same thing every time. I'm going to subtract pi over 6. Again, I would love for you to get a common denominator there and do that by hand, but for the sake of time, let's just use the calculator here. 1/4 minus 1/6 is 1/12, so that's pi over 12 is equal to 3 theta, negative 3 theta. Now, normally I would divide by negative 3, but I got a fraction on the other side, so dividing by negative 3 is the same as multiplying by negative 1 over 3. Dividing by negative 3 is the same as multiplying by negative 1 over 3, because negative 3 times negative 1/3 is equal to 1. That's the whole point in doing that. I want 1 theta, not negative 3 theta. So I do that because I got a fraction. That's going to save me having to flip and multiply. It's taking care of that part already. We got negative pi over 36. Well, that's not good because it's a negative answer. We don't want a negative answer. We want a positive answer. So we need to add 2 to that. So that gives us 71 pi over 36. You're going to get some weird looking answers on some of these. I'm just going to go ahead and warn you. Some of them are going to look a little strange. They're not necessarily going to be angles off the unit circle. It started as an angle from the unit circle, but through our work there, it turned into something different. But, yes. Okay. Okay, so let's fix 3 pi over 4. Subtract the pi over 6. So 3/4 minus 1/6. 3/4 minus 1/6. Math inner. 7 pi over 12 is equal to negative 3 theta. Same deal. Multiply it by negative 1/3. That's negative 7 pi over 36. Is equal to theta. We don't want the negative, so we got to add 2 pi. Well, I should have written that there. So that gives us 65 pi over 36. Okay, so that's 2 out of our 6 answers. Okay, now the other ones aren't going to be quite as lengthy because we went ahead and took care of this having to add 2 pi here at the end by making them negative coterminal angles to begin with. So that's good. One less step that we'll have to do with the other 4. So we've got negative 7 over 4 minus 1/6. Negative 23 pi over 12 is equal to negative 3 theta. Same deal, we multiply by negative 1/3. So we get positive 23 pi over 36. I left myself just enough room. So we got a positive answer that time. We don't have to go back and add 2 pi like we did with the first 2. Okay? Are we okay if I don't show the work on the other 3? Because it's the same steps over and over and over again. If you want to put the work on your paper, that is fine. Go for it. I'm just going to save myself some writing here. So subtracting the 1/6, divide by negative 3. Since I'm doing the calculator, I'm just going to do it like that. 17 pi over 36. Okay, do it again. Negative 15 over 4 minus 1 over 6. Enter. Negative 47 pi over 12. And that's going to give us positive 47 pi over 36. So all of our answers here end up giving us over 36. Because we're doing the same thing. We start with something over 4, we subtract a 6, and when we multiply by 1/3. So that's 41 pi over 36. Now, I always encourage you to check your answers. I would not go through and check all 6 of these. I would just check a couple of them because you're going to spend a lot of time checking if you do that. So let's see here, 2 sine -3 times, I don't know, let's pick a random one. Let's do 23 pi over 36. 23 pi over 36 plus pi over 36, or excuse me, pi over 6. That should equal the square root of 2. And it does. Okay, so I would say you're pretty safe to say if that one's right, then those other ones, if they look the same and you found them the same way, then you're probably okay with those solutions. Okay, so I don't know about you, but I feel pretty accomplished when I see work like this on my paper. I feel like I really did something. So hopefully you feel just as satisfied. All right, let's do another one, okay? Because I know these are the ones that tend to trip people up the most. So let's do one with cosine. We've got 3 plus the cosine of 3 theta plus 3 pi over 4 is equal to 7 over 2. Okay, again, same principle applies. Trig function got to be by itself. Right now we're adding that 3 in front. We need to begin by subtracting the 3 from both sides. So 7 over 2 minus 3 is 1/2. Okay, which is good because now that's a value from our unit circle. So we got to figure out where is cosine equal to 1/2. That would be at our pi over 3 angles. If you need to look at the unit circle to confirm, do it. Okay, pi over 3, x coordinates 1/2. 5 pi over 3, x coordinates 1/2. So pi over 3 is equal to 3 theta plus 3 pi over 4. 5 pi over 3 is equal to 3 theta plus 3 pi over 4. We had a 3 theta again, so we've got 6 answers. Okay, now this time it was a positive 3 theta, so this time I'm going to go with positive coterminal angles because I'm not going to end up dividing by the negative to reverse having the negative. So I'm going to add 2 pi over 3, so pi over 3 plus 6 pi over 3. That's going to give me 7 pi over 3 is equal to 3 theta plus 3 pi over 4. I'm going to add 6 pi over 3 to 5 pi over 3, which is going to give me 11 pi over 3 equal to 3 theta plus 3 pi over 4. And then I'm going to do it again. Add 6 pi over 3 to 7 pi over 3, so that's 13 pi over 3. 6 pi over 3 plus 11 pi over 3 is 17 pi over 3. For some reason my 4s are looking like 9s. Okay. Any questions about my setup of my 6 answers here? We'll see where those are coming from. Okay, let's solve them all for theta. Subtract 3 pi over 4. So we're going to get over 12 again. 1/3 minus 3 over 4. It's going to give me negative 5 pi over 12. We're going to multiply by 1/3. So that's negative 5 pi over 36. That is theta, but we got a negative again because we took 3 pi over 4 away from pi over 3. So we ended up in the negatives. So we just need to add 2 pi, 72 pi over 36. So that's what, 67? Yeah, 67 pi over 36. So again, some of these are going to look a little weird. They're not necessarily going to be angles from the unit circle. Next one, subtract the 3 pi over 4. So 5 over 3 minus 3 over 4. 11 pi over 12. That one's positive. So 11 pi over 36 is our second answer. Now, something you may want to do before you solve the other 4, you might want to go ahead and check one of these answers just to be on the safe side. I would encourage that. So 67 pi over 36. I don't know about you, but I'm a little suspicious about that answer. It looks a little weird. I'm going to check that one. 3.5. 7 over 2 is equal to 3.5. So check one of them. Pretty confident in it, so I'm going to go ahead and finish out the other 4. Okay, so 7 over 3 minus 3 over 4, 19 over 12, so 19 pi over 36 is going to be that answer. 11 over 3 minus 3 over 4, 35 pi over 36. 13 over 3 minus 3 over 4, 43 pi over 12, oh, I didn't multiply by 3, 43 pi over 36, and then one more, 17 over 3 minus 3 over 4, 59 pi over 36. Now, if you set them up right, you really shouldn't have to worry about this, but you do want to make sure that all of these are less than 2 pi. So 2 pi was 72 over 36. None of those exceed 72, so we're good. All our answers are between 0 and 2 pi. Okay, any questions? Let's do one more. I want to do one where we're dividing theta. It's a little, I mean, process is the same. The number of answers is different. Okay. -1 is equal to negative tangent of theta over 4 plus 5 pi over 6. We are not going to have 8 answers. Okay. Not going to have 8 answers. It's actually the reverse. We have fewer answers. And we'll look at why here in a second. Okay, -1 is equal to negative tangent theta over 4 plus 5 pi over 6. So trig function, not by itself. Not a whole lot going on, but we do need to take care of that negative in front of the tangent. So we divide both sides by -1. So we have +1 is equal to tangent theta over 4 plus 5 pi over 6. So tangent is equal to 1, where sine and cosine have the same value, so that's at pi over 4. Bless you. And that would also be at 5 pi over 4, where they're both negative. Okay, so premise is still the same. I'm not going to put down any other answers at this moment because I want to see what happens right here. So we subtract the 5 pi over 6. So 1/4 minus 5 over 6 gives us -7 pi over 12. That's equal to theta over 4. So to get theta by itself, we multiply by 4. So the 4 over 12 turns that into -7 pi over 3. That's a negative answer. Negative answers are not allowed. -7 pi over 3 plus 2, still negative. So I add 2 to it again. and that gets me 5 pi over 3. Okay, 5 pi over 3 is one of our answers. Let's solve the other one. 5 over 4 minus 5 over 6 is 5 pi over 12. And then we multiply by 4, so that's 5 pi over 3. That's a positive answer. It is less than 2. 6 over 3 would be 2, so 5 over 3 is less than 2. So that is our second answer. Now, if we were to try and do what we did a minute ago and produce more answers, let's just try one. Let's add 2 pi to pi over 4. So if we add, that's going to give us 9 pi over 4. Okay, so if we subtract the 5 pi over 6, 9 over 4 minus 5 over 6, 17 pi over 12, multiply by the 4, that gives us 17 pi over 3. Positive answer, but it's bigger than 2 pi, so we've got to take 17 over 3 and subtract 2. That's still bigger than 2 pi, so we got to subtract 2 again. That's less than 2 pi, but look, we already got that answer. So we don't need it again. So if we subtract 2 pi twice, we're going to end back up with 5 pi over 3, which we already have. So the moral of the story is that when theta is being divided by a number, you're not going to have extra answers. When it's being multiplied by a number, you're going to have that many times the normal answers.